Okay, 8b. Let's again do the definite integral, work out the answer, and then we're thinking about sketching the curve and looking for any limitations in the model. Already I'm going to expect some sort of limitations because I'm dividing by x. And when x equals 0, anything divided by 0 again tends towards infinity. So I'm going to be expecting problems around the 0 of this function, which is really what I'm after. That's normally what you're looking for these limitations. What happens as the function approaches 0, and if x is underneath, that is often the case. So let's do the definite integral first. So this equals the integral between 1 and 3. Well, if I split this into two fractions, 2x squared over x plus 1 over x, and integrate each of those terms separately, then that's the way forward. And we can see if we do that the 2x squared over x simplifies to 2x plus 1 over x dx. So to integrate this, all we do is integrate each term independently. So 2x becomes 2x squared over 2. Add 1 to the power, divide by the new power. 1 over x is the standard integral, becomes log x between 1 and 3. 2x squared over 2 simplifies to x squared plus log x between 1 and 3. And now all we've got to do is put in our limits. So this equals 3 squared plus log 3 minus 1 squared plus log 1. Put in the values, and you should get the answer in the textbook. It might be worth remembering that log of 1 is 0, which simplifies things, and 1 squared is just 1, so that makes the second bracket just 1. So you get the answer in the text. Now let's have a look at sketching the curve. This is not an easy function to sketch. Y equals 2x squared plus 1 over x. The sort of things to look for if you were sketching this function would be to think to myself, well, what happens as x equals 0, as I've sort of mentioned already, when x equals 0, then anything over 0 tends to infinity, so I'm going to be expecting it to be going up to infinity here. And equally, on the negative side, it's going to be negative infinity, so it's going to be doing something like that. Not so easy to see what happens after that. If you look at this, we've got an x squared term on the top and an x on the bottom. So as x gets bigger, x squared is going to increase more quickly than x. So you get to the point where actually the x squared term overtakes the x term effectively, and so y gets bigger and bigger. So we sort of get this sort of thing happening. And similarly here. And so I'd expect something like this. As far as the limitations of the model are concerned, it's this discontinuity here, this point here, that's important when x equals 0. We can see it shoots off to infinity. This discontinuity is what you've got to be careful of when you're looking at the model. And why does discontinuity occur? Because I've got divided by x here, which gives us this discontinuity. Just checking on autograph, if I plug that in, you can see the function there.